Okay, so a composite figure is a figure made up of two or more shapes. Okay. So if you look at this example here, this composite figure is made up of what shapes? How could you break it up? Okay, so we can cut it right here. So this is a rectangle, and then y'all are saying square. Okay, we're gonna see if it's a square or not. Okay, so if you break it into two or more basic shapes, you're gonna need to make sure you know the dimensions of those shapes that you break it into. So let's just see if we really have a rectangle. Okay, so if I cut right here, and I just put a little dot line to show that I'm cutting here. What are the dimensions of this rectangle? Yeah, 13 by 24. Okay, so then the remaining, what y'all say is square, would be what dimensions? 12 by 15. So it's not a square, it's a rectangle. Okay. How do we get the 15? 28 minus the 13 will give me a remainder of 15 for that part. Are we okay on that? So we see that it's two rectangles that are put together to make the composite. All right, so when you break the composite figure into basic shapes, you're going to need to label the parts of the dimensions. You're going to have to label the parts because those are the things you're going to use in your formula to find the area of each shape to get your composite area. So let's look at this one real quick. What could you break it up to? See if you can break it up into. Yeah.
A rectangle.
Okay, yeah. So if I cut right here, I would have a triangle plus a rectangle and a half circle. Yeah. Okay, so if I have a triangle, in a triangle you need to know the base and you need to know the height. And you gotta remember, and I'll just put a little side note, that the height is always perpendicular to the base. Because sometimes y'all pick the wrong part. You gotta remember it's the part that are perpendicular to each other. So the height, you're close. We need to find, we know the side is 5. We should see the base. What is the base? Yeah, the base is 6. Okay, this whole thing is 6. So do y'all see something? If I have that perpendicular bisector, you could use Pythagorean theorem, yeah, and that would get you to the answer. You didn't want to just see it because it's a triple. What is this little piece here? That's 3. If that's 3 and that's 5, this has to be 4. It's a triple. 3, 4, 5 is your first Pythagorean triple. Yes, we did. That's the first number I gave you to do Pythagorean theorem with.
What other triples?
No, not 4, 5, 6. Multiples of this. No, not 7, 8, 9. Okay, that's the multiple of this triple. There's a whole nother different triple. Yes. Okay, we'll come back to that. All right, what is the dimensions for the rectangle? This is 8 by 6, yes. Okay, and then that semicircle. We know that the diameter is 6, right? And the radius is 3. Okay. All right, so when you break it into the shapes, which you need the dimensions from each shape because you're going to have to do the formula to each shape. So like the triangle, I would do base times height divided by 2. For the rectangle, base times height. And then for the circle, pi r squared, but then divided by 2 because it's half of the circle. Okay? Pi r squared, but we would do half because it's half of a circle. All right, so you mean area? Circle, yeah, because there are going to be some circles in your composites. All right, so here are the things you need to make sure you know when you're breaking it down. Always break into basic shapes and label the missing parts. Break it into basic shapes and label the missing parts. Basically, label the dimensions. Give the formula for each basic shape, which is what I did above. There's each variable in the formula. Basically, substitute and solve. Okay? So these 4 steps are going to help you find composite areas, and also what we're going to look at is shaded area. Right now, this figure, example 3, was our figure for the very top. I want you to come up with the composite area for example 3. You already broke it apart on the very first example. Composite area. Yeah, the area of the whole thing. Okay, check. You should have hopefully got 492 meters square. How many did you get right on this one? Okay. All right, on the back. You are going to do this composite. I'm going to come by and give team celebration points based on the number of people that have the problem correct. There is more than one way to get to the answer. Okay? So work it out your way. Check with your group members. And then we also will give celebration points if you can come and explain how to solve, and we can see different representations. So I'm giving you time to do this now. When you have it and you think it's right, just raise your hand and I'll come by and stamp. Okay, so it was possible that you could look at the whole. So this is a kind of a way to, excuse me, this is a way to kind of eliminate some of your work and get to a quicker reasoning depending on the shape. This shape is concave. You see how this is caved in? Okay, so you can look at the whole rectangle, okay, and then talk about the part that's caving in. This is the part that we're going to take out. So you can take out the concave part and just subtract and get it in 2 steps. Okay, this is good right here. Or Joseph is showing a different way because there's more than one way to get to the answer. He cut it into rectangles, drawing your lines horizontal, and then adding up the pieces. You still should get to 96 centimeters square. Do we have questions on this? Okay. All right, so let's talk about this real quick because I want to talk about exact answers with circles and approximate answers. We see that the shaded, we got 2 things we got to do. We have the shaded in the corner here, and then we have the shaded of the triangle. So let's talk about just the shaded corner pieces. How would I get to that answer? Subtract which part? Yeah, the circle. Okay, so we take the area of square and minus the area of circle. Okay. I think y'all see the square is 100, right? Centimeters square. And then the area of the circle. Okay, so we're going to talk about exact answers and approximate answers. You're right on that, Lane. Okay, so to get the area of a circle, you're going to do pi r squared. Do y'all see that the radius of this circle is 5? Okay, because the diameter is 10 if I go across the square. All right, so if I want the exact answer, I leave it in terms of pi. Because on your calculator, this is talking about approximation too. On the calculator, if you come down to your keys at the bottom, where is it at? Oh yeah, there it is. Okay, let me get up my menu. So pi is over here in your keys, like to type in. And if you put in, the actual pi, I know it's tripping. Don't worry. How did I get to pi? There it is. Alright, so if I just put pi and I hit enter, it's gonna not stop at 3.14. Most of y'all do that approximation for pi. So pi is an irrational number. It keeps going on. The decimal keeps repeating. No special pattern. We'll show you why, hopefully with an investigation about that. But you're gonna get a different answer compared to if I do 25 pi. And I'm showing this because on your quizzes, on your test, it'll tell you leave in terms of pi or use pi in your calculations. So if I do 25 pi, I have that, compared to if I do 25 times 3.14. 3.14 has already been approximated, okay? So when I ask you to round to a certain decimal place, if I ask you to leave in terms of pi means you just leave pi in your answer. That is the exact answer, okay? If I ask you to approximate pi, then I'm going to tell you to approximate pi to 3. Okay? If you do, you would get different because rounding is happening before you multiply or divide, and it's going to change that output. So if I wanted the exact answer, because this is 25 pi, this would be the exact answer for the shaded corners. 100 minus 25 pi. They're not like terms. But if I do the approximation, you're right. So we had 100 minus, what was it, 70? Okay. All right, that's right. So no, we want the shaded region. So you're right, Michael. We have to take the triangle in consideration. So now we have to find. So this is our area of the shaded of the corners. Now I got to talk about this shaded here. Excuse me. So now I need to find the area of the triangle, which is base times height divided by 2. So what is the base and the height of the triangle in the center? Wow. Yep, the base is 5 radical 2. So 5 radical 2. What's the height? It's also 5 radical 2. Because this is a special right. I hope you saw that. It's a 45, 45, 90. Because these are...
So how do you know what the length is?
Because I know the hypotenuse is what? The hypotenuse is 10. Because it's the diameter of the circle. Okay? And so... Yeah. Alright, so... We're going to do 5 radical 2 times 5 radical 2 divided by 2. And we're just going to simplify that. What would that give me? 5 radical 2. Yeah, that'll give me 25. Okay, so I'm now taking this 25, and I'm now just going to add it to this answer. So 100 minus the 78.5 plus the 25. That's our approximate answer. Yeah, 46.5. That is the approximate answer. If I wanted the exact answer, okay, then I can only take the 25 and add it to the 100, right? So it'd be 125 minus 25. This is... You talking about the unit square?
570 squared.
You just can keep it like this. Yeah, because it's gonna end up being 70 square at the end. Yeah.